Each year, more than 1 billion pigs are raised across the globe. That number is so massive that if every pig were a person, we could repopulate an entire continent. But behind this astonishing figure lies something most people never see. An industry powered by cutting-edge technology, scientific precision, and relentless efficiency. When we think of pork, whether it's bacon, ribs, or sausages, we imagine something familiar, even comforting. But very few of us know what it really takes to bring that meat to the supermarket shelf. From the moment a piglet is born to the instant its meat is vacuum-sealed and labeled, a carefully orchestrated system is at work, combining biotechnology, robotics, artificial intelligence, and strict hygiene protocols. This is not the image of farming passed down from old textbooks or countryside tales. Today's pork production is one of the most automated and monitored food systems on Earth. Every gram of feed, every breath of air, every drop of water that enters a pig's life is tracked, controlled, and optimized. In this video, we're going to walk through every stage of that journey. You'll see how breeding is done in high-tech labs, how animals grow under the eye of AI-powered sensors, and how machines dissect, package, and label meat with near-perfect accuracy. We'll also explore the ethics, the science, and the hidden ingenuity that powers it all. Before we begin, don't forget to hit like and subscribe so you won't miss our next exciting videos. If you enjoy this video and its topic, comment with the number 1. We'll make more videos like this. And if you didn't like the content, feel free to comment with the number 2. It all begins long before a piglet takes its first breath. At the heart of modern pork production lies a process as sophisticated as any in the medical world: genetic selection. In today's breeding farms, choosing which pigs get to reproduce isn't left to chance. Instead, it's guided by data, algorithms, and high-tech laboratories. Only the healthiest, most efficient animals, those with ideal growth rates, strong immune systems, and superior meat quality, are selected. And the decision is often made not by farmers, but by artificial intelligence analyzing generations of performance records. Once a top-performing sow is chosen, the next step is artificial insemination. But this isn't a simple procedure. The semen used comes from elite boars whose genetic material has been frozen, tested, and perfected. In specialized labs, technicians evaluate the sperm's motility, concentration, and morphology. Every sample is screened to ensure it's not just viable, but genetically optimal. At the same time, the reproductive cycles of the sows are monitored down to the hour. Hormonal levels, behavior, even body temperature. Everything is tracked to pinpoint the perfect window for fertilization. Inside these farms, the environment is as controlled as a clean room. Temperatures are carefully regulated to promote fertility. Lighting systems are timed to influence hormonal rhythms. Every factor, from the timing of insemination to the positioning of the sow, is orchestrated to increase the chances of a successful pregnancy. Roughly 114 days after insemination, a sow will give birth to a litter of 10 to 14 piglets. But even that moment isn't left to chance. The birthing takes place in maternity zones specifically designed for both comfort and hygiene. Within hours, the newborn piglets receive their first and most crucial meal, colostrum. This thick, antibody-rich milk is essential to jumpstart their immune systems. Without it, the risks of infection and early mortality skyrocket. In the first few days, workers monitor the piglets closely, ensuring each one latches on, feeds well, and begins gaining weight. What's remarkable is that this entire process, from selection to birth, is now part of a global network. Genetic material from one elite pig in Denmark, for instance, may be flown to Brazil to improve a local herd. Some breeding pigs are even transported internationally by plane, treated like livestock royalty. These pigs don't go to slaughter, they become genetic ambassadors, helping regions around the world build stronger, more resilient herds. This global collaboration, fueled by science and logistics, has led to a quiet revolution. Pigs today grow faster, get sick less often, and convert feed into meat more efficiently than ever before. Behind every litter of piglets is a story of planning, precision, and international coordination. And that's just the beginning of their journey. Once the piglets are weaned from their mothers, a new and intense phase of their development begins. No longer reliant on milk, they're transitioned into specially formulated diets designed to meet the demands of rapid growth. These feeds aren't generic. They're crafted with exact precision to match the nutritional needs of young pigs, helping them build muscle, develop healthy organs, and strengthen their immune systems. The composition is adjusted week by week, often down to the gram. The environments where these piglets live are just as tailored. Pens are regularly cleaned, ventilated, and organized to minimize stress and avoid overcrowding. Group sizes are optimized so that each piglet has enough space to move, eat, and rest. Stress isn't just a welfare issue. It directly affects growth, disease resistance, and ultimately, meat quality. That's why many farms even use soft flooring and calming background sounds to maintain a steady environment. But what really sets modern feeding apart is the level of control and data behind it. Every pig's food intake is tracked in real time. Automated feeders dispense specific portions based on each animal's age, weight, and growth targets. These systems don't just follow a schedule, they adapt. If a pig misses a meal or eats less than usual, sensors alert the caretakers immediately. It's a safety net that replaces guesswork with responsive action. And the technology goes even deeper. Machine learning algorithms now analyze individual growth data to predict how much feed each pig will need, not just today, but in the days ahead. That means feeding is no longer reactive, it's proactive. Each pig becomes a personalized data profile, and every meal is part of a larger predictive model that aims to deliver ideal results with minimal waste. Water intake is also closely monitored. Filters ensure it's clean, while flow meters track consumption per animal group. Even slight drops in water intake can signal early signs of health problems, so these systems offer a crucial layer of preventive care. Feed additives play their part too. These include vitamins, minerals, and probiotics that support digestion and boost immunity without the need for antibiotics. The level of hygiene across the feeding phase is rigorous. Equipment is sanitized regularly, and any leftover feed is quickly removed to prevent mold or bacteria buildup. Pigs may not care if their feeders sparkle, but clean conditions mean fewer infections, faster weight gain, and better meat. Now compare this to traditional farming methods, where feeding is often done by eye, with a shovel or bucket, and where sickness might only be spotted when symptoms become visible. That system relies on experience and instinct, and while it's worked for centuries, it simply can't compete with the speed, accuracy, and consistency of data-driven farming. Smart feeding doesn't just lower costs, it increases yield. By tailoring feed to actual need, farms save on wasted ingredients and avoid overfeeding. Healthier pigs require fewer medical interventions, grow at a more predictable rate, and produce higher quality cuts. From a business perspective, it's more profitable. From a consumer perspective, it means safer, better regulated food. What's unfolding in these barns isn't just growth, it's transformation. From the moment piglets move on to solid food, they're part of a carefully calibrated system where science, sensors, and algorithms converge to turn milk-fed piglets into full-grown animals in record time. When pigs reach their target weight, around 100 kilograms, it marks the end of one journey and the beginning of another. Leaving the familiar rhythms of the farm, they're carefully moved toward transport. But even this step, often overlooked, is a critical part of the entire process. Because how an animal is treated in its final hours doesn't just affect its well-being, it can directly shape the quality of the meat that ends up on your plate. To start, farms use gentle handling techniques and smooth-sloped ramps to guide pigs into the trucks. The idea is to eliminate sudden movements, sharp corners, or anything that might cause fear or injury. Floors inside the transport vehicles are lined with straw or rubber mats to give animals stable footing. Even the material used to guide pigs, often soft boards or canvas panels, is designed to reduce panic and avoid bruising. Once on board, the focus shifts to comfort during the ride. These aren't just regular trucks, they're specially designed, temperature-controlled units. Inside, ventilation systems regulate airflow, while real-time sensors monitor humidity and temperature. If things shift outside of acceptable ranges, alerts are sent immediately to the driver or handlers. Because for pigs, heat stress or poor air circulation during transport isn't just uncomfortable, it can result in muscle damage, pH imbalance, and tougher meat. Regulations play a major role here. In most countries, there are strict limits on how long pigs can be transported without rest. Some laws cap the duration at 8 hours, others allow more time but require mandatory breaks with water and shade. Ventilation standards are also clearly defined, ensuring consistent airflow throughout the trailer, not just at the front. These rules aren't just paperwork. They're enforced with random inspections and hefty fines for violations. When the pigs arrive at the slaughterhouse, they aren't rushed straight to processing. Instead, they're led into a quiet holding area, away from loud machinery and bright lights, where they can rest and recover from the trip. This resting period, which can last several hours, is essential. It lowers cortisol levels, reduces muscle tension, and helps the animals regain calm. The result? Better texture, color, and water retention in the meat. In fact, one of the first things inspectors check is whether this rest period has been respected. Around the world, the standards for humane animal transport vary, but the direction is clear. In Europe, for instance, the 5 freedoms model influences legislation: freedom from pain, discomfort, fear, hunger, and to express natural behavior. In countries like Denmark and the Netherlands, which export huge volumes of pork, animal welfare is deeply integrated into national branding. Meanwhile, in the United States, the Pork Quality Assurance Plus program gives producers specific guidelines to follow for handling and transport. Some nations even require real-time GPS tracking of livestock vehicles. Whether it's in North America, Europe, or Asia, the trend is moving toward greater transparency and animal dignity, even in the final stages of life. Because at this point, every small detail matters. Not just ethically, but economically, environmentally, and nutritionally. Inside the walls of a modern slaughterhouse, the atmosphere is clinical, organized, and controlled to the second. Every step has been engineered not only for efficiency, but also to meet strict ethical, sanitary, and safety standards. The goal is clear: minimize suffering, preserve meat quality, and ensure traceability from the very first moment. When pigs enter the facility, they're directed into quiet, low-stress holding areas where they're allowed to rest and acclimate. From there, they're moved through chutes toward the slaughter area. The first technical step is stunning, done using a controlled electric current that renders the animal immediately unconscious. This method is considered one of the most humane available. It ensures that the animal doesn't feel pain or fear in its final moments. The timing is critical. Stunning is followed within seconds by the bleeding process, where a precise incision is made to ensure rapid, complete drainage. This not only preserves hygiene, but is essential for meat quality, color, and shelf life. Once bleeding is complete, the carcass is transferred to the scalding tanks, large baths of hot water designed to loosen hair and dirt. It's a brief submersion, followed by mechanical dehairing machines equipped with rotating rubber paddles that gently scrape the skin clean. The process ends with a thorough rinse using pressurized water jets, leaving the exterior free from visible contamination. Now begins a new level of precision. Automated saws, perfectly calibrated, split the carcass into symmetrical halves. These machines operate with millimeter accuracy, reducing human error and standardizing output. Next, the internal organs are carefully removed in a process known as evisceration. Different teams handle different parts, one for gastrointestinal organs, another for vital organs like heart and liver. Each tool used is sterilized after every carcass, and strict separation between clean and dirty zones prevents any chance of cross-contamination. Before the meat moves on, it passes through advanced scanners, X-ray, and optical systems that inspect for anomalies invisible to the naked eye. These technologies can detect bone fragments, abscesses, or signs of disease. If anything unusual appears, the line pauses, and inspectors investigate on the spot. It's not just about safety, it's about maintaining trust in every single product that leaves the plant. Traceability is a central part of the system. Each half carcass is tagged with a unique code that includes the farm of origin, date of slaughter, and batch number. That code follows the meat through every step of the supply chain, right up to the packaging label. In the event of a recall or health concern, this system allows authorities to trace a product back to its source within hours. But machines don't run everything. Human oversight is constant. Trained quality assurance personnel are stationed throughout the facility, checking temperatures, cleanliness, and visual signs of spoilage or inconsistency. Samples are taken regularly for lab testing. Every workstation is cleaned multiple times a day, and staff follow strict hygiene protocols, changing gloves, washing tools, and wearing full protective gear. One misstep could compromise thousands of kilos of meat. As automation becomes more central to slaughterhouses, debates have emerged. Can machines truly replace human judgment when lives and ethics are involved? Some argue that robotics reduce stress and increase consistency. Others caution that over-reliance on automation may lead to blind spots, especially in ethical oversight or subtle animal health issues. What's clear is that technology plays a pivotal role, but it's not a substitute for accountability. In this space, precision isn't a luxury, it's the foundation of a system that balances speed, safety, and responsibility. Every cut, every scan, every sanitation step matters. Because what happens here doesn't just define how meat is produced, it defines whether consumers trust what they're eating. Once the carcass has been split, inspected, and cooled, it enters the next phase, transformation. This is where industrial precision meets culinary tradition, where meat becomes product and raw material is sculpted into familiar forms. The first step is butchering, and here, automation leads the way. Robotic arms, equipped with ultra-sharp blades and programmed with thousands of cutting patterns, perform clean, consistent cuts in a matter of seconds. Each movement is calculated down to the millimeter, minimizing waste and maximizing yield. As the large cuts move along the conveyor belts, they enter the deboning stations. But these aren't manual tables with knives and cutting boards. They're vision-guided systems that scan the shape and density of each piece of meat in real time. Using this data, they locate the bones precisely, then direct mechanical tools to remove them with surgical accuracy, without shredding or damaging the surrounding muscle. It's not just efficient, it's art guided by algorithm. Next comes classification. Some cuts, like the loin, ribs, or tenderloin, are separated for high-end retail or restaurant markets. Others, like trim and fat, are sorted into industrial-grade bins for further processing. Every gram is accounted for. This is where nothing goes to waste, and it's here that the journey of the sausage begins. The selected meat, often a mix of lean muscle and fat, is fed into massive stainless steel mixers. Water, ice, salt, and a blend of spices are added. Garlic, paprika, sugar, or pepper, each batch has its own carefully calibrated recipe. Once mixed, the blend moves to the emulsifier, a high-speed grinder that breaks the meat into a fine, uniform paste while maintaining a cool temperature. Friction is managed carefully so the meat doesn't partially cook during mixing. From here, the emulsified mixture is pumped into casings, either natural, made from cleaned animal intestines, or synthetic, made from edible cellulose or collagen. These casings are filled by machines that portion each link perfectly, knotting or twisting them with rhythmic precision. Depending on the recipe, the sausages are then arranged on racks and moved into steam ovens, where they're cooked at specific temperatures to reach internal doneness without drying out. In some plants, the sausages are taken through a smoke chamber. This isn't just for flavor, it also extends shelf life and enhances color. Whether it's a light beechwood smoke or a darker, hickory-rich finish, the settings are digitally programmed and closely monitored. After cooking or smoking, the sausages are rapidly chilled to lock in texture and prevent bacterial growth. Packaging is the final touch. Robotic arms place the cooled sausages into vacuum-sealed trays. Labels are applied automatically, and each pack includes traceability data, batch code, processing date, and origin. Before shipping, each pack passes through multiple quality checks, weight sensors, seal inspections, even oxygen detection to ensure no air has leaked into the packaging. And sausage isn't just sausage. In gourmet lines, ingredients like chunks of cheese, fresh herbs, or diced vegetables are mixed into the meat before stuffing. These additions require even tighter quality control to guarantee even distribution and avoid spoilage. Temperature must remain within strict limits during mixing, and additional preservatives or acidity regulators are often used to balance shelf stability with natural flavor. What's impressive isn't just the speed or volume, though thousands of sausages can be produced per hour, but the level of control at every step. Food engineering plays a key role in extending shelf life, reducing pathogens, and ensuring flavor consistency. Every factor from salt content to water activity is optimized to create a product that looks fresh, tastes great, and remains safe for weeks. And the sustainability? It's built into the system. Fat, bones, cartilage, anything not used for premium cuts or sausages is repurposed. Some go into pet food, some into gelatin, some into biofuels. In a modern meat plant, waste isn't just avoided, it's engineered out of the equation. What ends up as a simple pork chop or sausage on your plate is the final step in a journey that begins long before you ever walk into a store. From carefully selected genetics and lab-monitored breeding to AI-guided feeding systems, precision slaughter, and robotic packaging, every stage of pork production is powered by layers of technology, regulation, and scientific oversight. It's a process designed for efficiency, but also for safety, consistency, and traceability. And yet, most of us rarely think about how that food got there. The journey from birth to bacon isn't just farming anymore. It's food engineering on a massive scale, where biology, data, robotics, and logistics come together to feed millions. This is the silent machinery behind our meals. Invisible, but vital. What's striking is how much complexity is hidden in something so familiar. Every bite of pork we consume is the product of global systems, ethical debates, economic choices, and technical mastery. It's not just a question of how food is made, but how much we know or choose to know about that process. So now I'm curious, has this changed the way you see pork? Do you think food producers should show us more of what happens behind the scenes? Should transparency be a standard, not an exception? If you found this deep dive informative or eye-opening, let us know. Like the video, share it with someone who cares about where their food comes from, and don't forget to subscribe for more stories at the intersection of food, tech, and ethics. The way we eat is changing, and understanding it is the first step to making smarter choices.